Welcome to Chibuzor Math Physics. In today's video, I will be taking you through set theory. Set theory is one of those basic mathematics that you are expected to do first as you gain entrance into the university. Of course, with other algebraic math, this doesn't mean whether you intend to do mathematics or not, but this is one of those compulsory mathematics that is expected of everyone. So let's get into what actually is a set. So basically, a set is nothing but a set. It is a collection of objects, things or symbols which are clearly defined. So the object must be clearly defined, and that is exactly what we mean when we talk about set. We know the individual objects in a set, they are called the members of the set. So you'll be talking about the individual object of the set. This is what we call the members, and we know you can call it members or maybe elements of the set. It can as well be referred to as the element of the set. Let's see, in set theory there are symbols that we need to recognize when we talk about set. We can talk about a set in the form of, let's take example of a set. We have set A, and then we can put with this bracket 1, 3. Maybe we have another set B to be equal to 2, maybe 3, 9. All these are sets. We can even have set C to be equal to 3, 9. So this that we have here is what we call the collection of objects. They are called the collection of objects. A full set can intersect to each other, and when that happens, we have symbols that we use to refer to intersection. So I would like to introduce those symbols as we take example in set theory and try to solve that. So let's take these symbols that are very important in our dealings with set theory. We have what we call intersect. This sign here implies that we are referring to intersect. When you have things like this simply means union of the set. We have a symbol for proper subset. This means proper subset. We have another symbol. It means subset. We have this symbol with a bit cross there. That means not a proper subset. And many others. We have this This means superset. We have this symbol. This means is a member. This means not a member. So it is good to pay attention to all these symbols as we are going to be using them to find in dealing with set theories that we might use examples. As you proceed in mathematics, you will discover that some of these symbols, like here we have got this is a proper set. In reanalysis, which is purely it is pure mathematics, we also refer to this symbol as it is contained in. This symbol will be referred to as contained, which this and this we use them to refer as this element is contained or it is not contained. So you will find out that we will be manipulating all these symbols throughout our studies in mathematics. But for the basic knowledge that you need in this unit, when we talk about basic maths in terms of algebra, you might need to refer to this symbol as a proper subset. This is a subset, and this is not a proper subset. It is union, interset, superset, is a member, and this is also not a member. Of course, as you proceed, you will even discover more other symbols like things like this, which we now mean epsilon. So when you proceed in mathematics, you will dive into more complex analysis. So let's take example in terms of set theory. Equation. Let set A. Let A be 1, 4, 3, 4, 5, 6. And B to be 1, 3, 5, 7, and 9. B two subsets of the universal set. So these two sets, A and B, this set A and set B are two subsets of this universal set. It means that they were taken from the universal set. So the question is to find A union B. This simply means union. So we are to find A union B. So we are going to list all the sets that are in A and they are also in B. That means that those two sets are in union. And if you watch, we simply have 1, 2, 3 because the sets that are in union, A union B, would be, so this would be 1, 2, we have 3, 4, we have 5, we have 6, 7, and we have 9. These are the sets that you can either find in A or B. So we write all of them without repeating any of these values. This is 1. In A, we have 2, we have 3, we have 4, we have 5, we have 6. But in B, we also have 7 and 9. That's why we have 7 and 9. And this will be the correct answer to this question. A. So let us find A intersection B complement. But here they have introduced something called complement of a set. What is a complement? A complement of a set is simply the set that is not in the given set. So if we have A and I ask you to find the complement of set A and set with B, it simply means the set that is not in A, that element that is not in A. But here we've been given A intersection B complement. So first of all, let us find A intersection B. A intersection B is the set that is in A and is also in B. So those are the intersect. Those are the intersect. So here you simply note those sets that are intersect. A intersection B, here we have set 1, we have 1, we have 2, we have we don't have 2 here. So we have 1, we have 1, 3, and 5. Let's have that. It is 1, we have 1. This is set A. It is given by 1, 2, 3. 1, 2, 3. This is 1. We have 2, and then we have 3. But talking about the intersect, we know that we have 1 here. We have 1. We have 3. We have 3, and then we have 5. And then there is also 5 in set A. So both sets have these 3 elements, and those 3 elements are called the intersect. But we need the complement of those 3 sets. So we simply take all the sets in the universal set except the intersect. So therefore, A intersection B complement will be 2, 4, 6, 7, 8, and then 9. This will become A intersection B complement. So we've removed those elements that intersect A and B, so they are not among, because we are looking for the intersect, the complement of those 2 sets, and that's exactly what we mean. And the last one here, we are to find A difference B. A difference B is simply the difference between these 2 sets. This will be 2, 4, and 6. 2, 4, and 6. The element in A that is not in B. We know that we have 2 here, we don't have it in B. We have 4, we don't have it in B. We have 6, and we don't have it in B. All other sets like 1, 3, 5, 7, all those other sets are in B. So therefore, this is what we call A intersection, A difference B. And this is A intersection B complement, and this is A union B. Hope you've enjoyed. In the next video, we will continue dealing with set, but I would like to introduce how we have to find the equation of the line using the gradient formula. F is equals to mx plus c. Of course, those are required basic maths that we need as we join the university. See you in our next video. Galagash.